Okay, these are the notes for 5-2. I actually already recorded this once, but the file kind of cruded out on me. So I'm going to give you the notes again. They're already written, but I'm just going to talk through them. Okay, obviously you can pause the screen if you want to copy everything down first. Alright, this section, again, we're in Unit 4, and we're talking about special segments in triangles and special properties of triangles. So everything we're doing in this unit has to do with triangles and the properties that they have. Hold on. Alright, so two special segments is perpendicular bisectors and angle bisectors. Now you already know what these words are, but you're going to see what they look like inside of a triangle. So perpendicular bisector, for those of you who have forgotten the definition, perpendicular means 90 degrees, bisector means it goes to the midpoint, right? So here is a triangle, and I've drawn all three perpendicular bisectors of all three sides. Notice each one goes through the midpoint of a side, and each one is also perpendicular to the side. Now, notice that they all intersect at the same point. That's not a coincidence. Every perpendicular bisector, no matter what the triangle is, will always intersect all together at the same point. When three lines intersect at one point, it's called a point of concurrency. And this one has a special name. When it's formed by perpendicular bisectors, it's called a circumcenter. Okay? Then we had angle bisectors. You learned angle bisectors on Tuesday, so hopefully you remember that word. Angle bisectors cuts an angle into two congruent angles, so it basically just splits the angle in half. Notice I've drawn that angle bisector, I've drawn that angle bisector, and I've drawn that angle bisector. Again, they all intersect at one spot, and that point of concurrency is called the incenter. Now, these words are actually from section 3, so we'll see them again next week. And you won't actually see your perpendicular bisector and your angle bisector inside the triangles today. Today's lesson is going to focus mainly on these next two theorems. So save this information for tomorrow. I just wanted to have it on there so you can see how this relates. Most of your problems are going to look like this. The perpendicular bisector theorem basically says if this is a perpendicular bisector, again that means it goes through the midpoint and it's 90 degrees, any point on this line is going to be the same distance to the endpoints of the line. And that's kind of common sense. Basically, the rule of thumb in this section is if it looks equal, it probably is. I usually never tell you to assume that, but in this section, it's pretty much true. Everything that looks equal really is equal according to these theorems. If you have a point on a perpendicular bisector, it is going to be the same distance. If things are equal, all you do is set them equal and solve. Okay? The next theorem. Angle bisector theorem. Again, this is an angle bisector. It cuts the angle in half. What this theorem says is that if I have a point, and it's on the angle bisector, then it is equidistant to the sides. Now when I say equidistant, I always mean perpendicular because it's always going to be the shortest distance. This distance is not going to be the same as that distance, right? This is going to be shorter because it's perpendicular. So this distance will be the same as that distance. And again, when you see this picture, if it looks equal, it probably is. Okay? Alright, the next example I do want to redo for you so you can see me work it. Okay? We're going back to the coordinate grid. If I give you 2 points, I expect you to be able to find the equation of the perpendicular bisector. That's one of your learning goals from Unit 2 is being able to find the equation of a line. So, let's think about what this word means again. Perpendicular bisector. Perpendicular means 90 degrees. It also means negative reciprocal slopes. Bisector means midpoint. So, we've got some ideas of what we're going to have to do. We're going to have to do midpoint, and we're obviously going to have to do slope before we can find the equation. So, midpoint. That is the equation of midpoint. So if I plug in, I'm going to take my x's, 4 plus 2 over 2, 6 plus 0 over 2, which is going to give us 6 over 2 and 6 over 2, which is 3, 3. So our midpoint is 3, 3. That is the point that our line will go through. We will need that later. We also need the slope of our line. We know that it's going to be perpendicular to this line, so first we need to know the slope of this line. Y'all know the slope formula, so I'm not going to do that one. Slope of AB. Slope of AB is going to be 6 minus 0 over 2 minus 4, which gives you 6 over negative 2, which is negative 3.
Bus 429 is now 787. Bus 429 is 787.
Okay, but this isn't the slope we want. Remember, we want perpendicular, so what do we have to do? Negative reciprocal. If I put that over 1, my perpendicular slope is 1 over 3. So here is my slope, here is my point. X, Y, M. Hopefully y'all know what to do from there. Y equals mx plus b. My y is 3. My m is 1/3. My x is 3 plus b. That's 3 equals 1 plus b minus 1. B equals 2. So I have my b and I have my m. Y equals 1/3 x plus 2. And that is my final equation. Alright, so that is finding the equation of a perpendicular bisector.